This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today we're diving into the fascinating world of educational technology, specifically a really cool interactive simulation, the musical keyboard simulator. It's designed to teach about sound and music, and it's all web-based.
Yes, it's a great example of how technology can make learning more engaging and accessible.
It's not just about playing notes, it's about understanding the physics behind the music. What specifically makes this simulator so effective?
The interactivity is key. Students can manipulate the amplitude, directly seeing and hearing the effect on the sound's loudness. This hands-on approach fosters a deeper understanding than passive learning.
Right, and it's all done through a simple, intuitive interface. Let's explore the details. Let's start with the simulator's features. You mentioned the amplitude slider. How crucial is that element in the learning process?
The amplitude slider is fundamental. It allows students to directly control the volume, visually connecting the slider's position with the resulting sound intensity. This concrete experience reinforces the concept of ramplitude and its relationship to loudness. It's not just abstract, it's something they can manipulate and observe the consequences.
I see. And the clickable keyboard, is that just a fun addition, or does it serve a pedagogical purpose?
It's far more than just fun. The clickable keyboard, combined with the option to use a physical keyboard, provides multiple avenues for interaction. This caters to different learning styles and preferences, making the experience more inclusive and effective. It also allows for exploration of different notes and their frequencies.
The reset button seems simple, but its importance shouldn't be overlooked.
Absolutely. The reset button is essential for allowing students to easily start over and experiment without having to reload the entire simulation. This encourages experimentation and risk-taking, crucial for effective learning.
How does this simulator translate into practical classroom applications? What are some specific learning goals it can help achieve?
It's incredibly versatile. It can be used to demonstrate the relationship between amplitude and sound, explore musical notes and their frequencies, and even introduce concepts like waveforms. The interactive nature makes it ideal for demonstrating the physics of sound in a way that's both engaging and memorable.
Right. Beyond the immediate learning goals, how does it contribute to a broader understanding of physics and music?
It bridges the gap between abstract concepts and tangible experiences. Students aren't just memorizing definitions, they're actively constructing their understanding through experimentation and observation. This hands-on approach is far more effective in promoting long-term retention and deeper comprehension.
The simulator is an open educational resource, or OER. What does that mean for educators and students?
Being an OER means it's freely accessible, modifiable, and redistributable under a Creative Commons license. This removes financial barriers to access, allowing educators worldwide to use and adapt the simulator to their specific needs. It promotes equitable access to quality educational resources.
And what about the licensing for commercial use?
Commercial use of the underlying easy JavaScript simulations library requires a separate license, but the simulation itself is freely available for educational purposes. This ensures that educators can use it without worrying about copyright restrictions.
The provided embed code makes it easy to integrate the simulator into other websites and learning platforms. How significant is this feature?
The embed code is a game changer. It allows educators to seamlessly integrate the simulator into their existing online learning materials, creating a more cohesive and engaging learning experience. It eliminates the need for students to navigate to a separate website, streamlining the learning process.
How does this virtual simulation compare to traditional hands-on experiments in teaching about sound?
Virtual simulations like this offer several advantages. They provide a safe and controlled environment for experimentation, eliminating the need for expensive or potentially hazardous materials. They also allow for repeated trials and easy manipulation of variables, which can be difficult or time-consuming in a traditional lab setting. However, traditional hands-on experiments still have value in developing practical skills and fostering a deeper understanding of the physical world. Ideally, a blend of both approaches is most effective.
The simulator effectively uses multimedia, combining visual and auditory elements. How does this enhance learning?
Multimedia learning leverages multiple sensory channels, leading to improved comprehension and retention. The visual representation of the keyboard and amplitude slider, combined with the auditory feedback of the sounds, creates a richer and more engaging learning experience. This multisensory approach caters to diverse learning styles and enhances overall understanding.
This simulator is part of a larger collection of resources from the Open Source Physics at Singapore project. What other types of simulations are available?
The Open Source Physics at Singapore project offers a wide range of simulations covering various physics and mathematics topics, including mechanics, electromagnetism, optics, and more. This comprehensive collection provides educators with a wealth of resources to support diverse learning needs and curriculum requirements. Many of these simulations are also designed to be easily embedded into websites.
Are there any potential drawbacks to using simulations like this in education? How can these be mitigated?
While simulations offer many advantages, it's important to acknowledge potential limitations. Over-reliance on simulations could hinder the development of practical skills and hands-on experience. This can be mitigated by integrating simulations with traditional lab work and real-world applications. It's also crucial to ensure that the simulations are accurate and aligned with the curriculum's learning objectives.
Let's circle back to the importance of interactivity. How does the musical keyboard simulator's interactive design contribute to student engagement?
Interactivity is paramount in fostering student engagement. The hands-on nature of the simulator allows students to actively participate in the learning process rather than passively receiving information. This active engagement leads to increased motivation, improved comprehension, and enhanced retention. The immediate feedback provided by the simulation further reinforces learning and encourages experimentation.
The study guide mentions kinematics. While not directly central to the simulator, is there any indirect relevance?
While the simulator focuses on sound, the underlying principles of wave propagation have connections to kinematics. The movement of sound waves through a medium can be analyzed using kinematic concepts, although this is not the primary focus of the simulation. It's a subtle connection that could be explored further in a more advanced context.
The study guide includes a quiz. Let's briefly touch upon a couple of the questions and answers. What is the primary purpose of the simulator?
The primary purpose is to provide an interactive learning tool for understanding sound production and the relationship between amplitude and loudness. It allows students to experiment with these concepts in a safe and engaging environment.
Right. And what about the question regarding the use of a physical keyboard?
The ability to use a physical keyboard provides an alternative input method, catering to different learning styles and preferences. It also helps bridge the gap between the virtual and physical worlds, reinforcing the connection between the simulation and real-world musical instruments.
This discussion has highlighted the many strengths of the musical keyboard simulator. Its interactive design, open source nature, and ease of integration make it a valuable tool for educators.
Absolutely. It's a prime example of how technology can enhance learning, making abstract concepts more accessible and engaging for students.
That was a great discussion. Thank you for sharing your expertise.